My name is Beyang. I'm the CTO and co-founder of a company called Sourcegraph, and I'm here today to talk about how we built this thing called Cody, an open source AI coding tool specifically designed for large, messy code bases. So anyone here work in a large, messy code base? Okay, I think most of you. I think most of the code, especially the production code in the world, is large, messy, and has been around for a while. So I want to start off by talking about kind of like two personas that I'm familiar with. So we're kind of living through an interesting world right now in the midst of an AI revolution. And so I have two friends of mine who I'll call Robbie and Bob. Okay, so Robbie's on the left-hand side. Robbie is all in on the AI revolution. So he's like, AI is already better than humans at most things. LLMs write 90% of my code these days. I just built an entire app just by talking to my phone. And I'm going to teach you how to start a billion-dollar company with my $10 a month newsletter. All right, so he's like all in. And then Bob is sort of the opposite end of the spectrum. So Bob says things like, AI is more of a toy right now. It's a cute toy, but it's still a toy. It can write simple functions, it can do kind of basic line-by-line completions, but it messes up a lot, and oftentimes it makes so many mistakes that it would have been faster if I just written the code myself. So my question to you all here is, who resonates more with your experience these days? Like, who's in kind of like the Robbie camp? Like, AI is the future, it's already here. All right, cool. So we got a couple folks. And who's more in like the Bob camp of things? A little bit skeptical. All right, I think most of you, the sort of natural technical skepticism, I think, that developers have about any sort of new technology. I think it's a healthy skepticism. So we asked ourselves this question at Sourcegraph. So, we build a code search engine that helps humans understand code traditionally, but we're also building this thing called Cody that we're trying to make useful in large production code bases. And so we're asking ourselves, like, we're talking to our users, and we talk to both Robbies and Bobs a lot. So who is right? And we kind of came to this realization, it's like, what if they're both right? Now, how could that be? Because they're basically expressing, diametrically opposed opinions. And I think what it comes down to is maybe what your sort of like day-to-day lived experience as an author of code looks like. So, which type of code or coding is taking up your time. So are you working on a side project, or maybe you're like a developer influencer, that a lot of those these days on Twitch and Twitter, or maybe you're someone new to coding entirely. And so you're working in mostly greenfield code. You're creating an app from scratch. LLMs are pretty good at doing that these days, and most of the code that you're working with is code that you wrote yesterday or recently. But if you're more of a Bob, you might spend all your day in legacy code. I think a lot of professional developers spend most of the day in legacy code. Almost by definition, if your code is in production, if it's powering users, if it's driving revenue, it's probably been around for a while. It's probably had a lot of contributors, a lot of history. It's probably got its fair share of dragons and beasts and buried bodies in the code base. And so how does that affect your perception of the efficacy of AI for coding? Well, I think what we've noticed is that there are certain tasks that are hard for humans but seem easier for large language models, and vice versa. Certain tasks that seem very difficult for large language models that seem relatively easy for humans. So if you're writing a new application from scratch, let's say you're building like a new React app, as a human, even if you're an expert front-end developer, that's kind of hard. Like even, me, I've been coding for more than a decade now. I've done a lot of front-end frameworks. When I create a new application from scratch, I still have to spend, a good 30 minutes, maybe an hour looking up documentation. I got to figure out how to like spin up, what's the latest way of creating a React app? Is it create React app? Is it Next.js? Is it like some newfangled thing that came out in the last 6 months or so? Whereas if I just ask an LLM to do that, LLM can produce like a Flappy Bird clone in like 30 seconds, and it just works, and it's pretty impressive. On the other hand, if I'm inside a legacy code base and there's like a P0 that's brought down our website, if I'm the type of senior developer that has a lot of context into that code base, I can submit a 2-line patch to that pretty quickly and bring the site back up. If I ask ChatGPT how to do that, boy, we're going to be here for a while. we might be here all of eternity because it just does not have the context to know what 2 lines need to be changed to fix that error. And so, the observation for us is that new code and legacy code are really different beasts, right? The new code is like the baby dragon. It's cute, it's adorable, it's lovely, everyone loves it. You made a new thing from scratch. That's the joy and that's the delight. In some sense, it's kind of like the creative spark that got a lot of us into programming in the first place. Like most of us probably wrote our first few lines of code in not a legacy code base, and just like a code base from scratch. And that spark of creation is really exciting and interesting. But our day-to-day lives as professional engineers are kind of spent fighting the dragon on the right. It's a very different beast. It involves acquiring a lot of context for the code base, figuring out how all the existing code exists. And so the question is, how do we slay the dragon on the right? How can we make developers more effective at that? And hopefully bring the experience of working in legacy code closer to the magic of working in a new code base. And so, in a nutshell, that's why Sourcegraph exists to a certain extent. So, my co-founder and I were both developers by trade. We both spent the entirety of our careers working in large legacy code bases. We spent over 10 years building the world's best code search, specifically targeting at allowing humans to understand existing code. We're now used and trusted by a large swath of open source maintainers as well as developers in the Fortune 500. So we're pretty big in the Kubernetes community. I see a lot of screenshots from that community of people sharing search results into how Kubernetes works and using that to transfer knowledge. And we're also fortunate to have a lot of great customers using our code search and AI coding tools. Everyone from forward, very futuristic companies like Tesla, and Palo Alto Networks is another big customer, as well as kind of customers with a lot of legacy code. So 3 of the 5 largest banks in the U.S., folks like Leidos, who some of you may be familiar with their logo. If you flew here, all the latest airport security machines have their logo. And so we're really adopted by this wide range of people and enterprises. But the really common point is all of these folks have large production code bases, and they have trouble making people productive in them. And so that's our specialty. We really wanted to make an AI coding tool that worked in the context of your day-to-day experience as a professional dev in these sorts of code bases. So I want to talk through some of the problems that we've encountered when using LLMs to do basic coding tasks in real-world code bases, and also share some of the solutions that we've come up with to solve those problems. And maybe we'll do a little bit of live coding too, knock on wood, or the proverbial wood, because it's always a risk doing live demos, but we'll see how it goes. Okay, so problem number 1 that we encountered is that the LLM doesn't know to use your preferred libraries. So if you go drop into ChatGPT and you ask it something like, hey, write a Python script that detects all the pedestrians in an image. It's like a pretty basic computer vision task. It's going to use OpenCV, because OpenCV is the kind of de facto standard for doing object detection. It's been around for probably longer than I've been coding, probably stretches back to the early 2000s or maybe the 90s. There's simply just a lot of training data available for OpenCV. And so if you ask any of the latest frontier models, whether it's GPT-4o or Claude 3.5 Sonnet, they're all going to default to OpenCV. But what if you don't want to use OpenCV? What if you use something different internally? What if you have your own internal libraries and packages and frameworks, or your own set of coding standards? How do you steer the LLM to make use of that? It's not something that works super well with just kind of existing LLMs. Another problem that we encountered ourselves and saw many of our users encounter is this problem of hallucination. So how many of you have asked ChatGPT or something like that, hey, how do I use this API? And you got back a response that looked pretty much correct. So, I'm asking it to show me how to use the Sourcegraph API to find all the references for a given symbol in code. And we have a GraphQL API. It emitted GraphQL, and this looks very plausible. It passes the repository name and the commit, and then a query describing what symbol it wants references for. Seems pretty sensible, right? So who can spot the hallucination here? Probably no one, because you're not familiar with the API. But even for us living in this code base every day, it's actually quite difficult. But it turns out that references node is hallucinated. So that doesn't actually exist in the real API. And so if I just blindly copied pasted this in, it might seem fine at first, but it'll come back and bite me later, and maybe it'll cause subtle bugs in my implementation, and I'll have to waste a bunch of time later fixing this error that might end up costing more time than I saved using AI. All right, so there's one weird trick will make the quality of AI code generation much better. And the weird trick is all you got to do is you got to find a usage example from somewhere out there, maybe in your code base, maybe from some other repository. You just got to find a usage example, and you paste it into the context window and say, here's an example of using that API. Now go and answer my question now. And that one act of just including like a single good usage example all of a sudden improves the output substantially. So I didn't even paste in a GraphQL usage example. This is from like the TypeScript client or something. But it was able to pattern match against the correct usage of that API and interpolate it into a response that actually is a working GraphQL query. So that's done, right? That's the end of my talk. All you got to do is comb your code base in the far corners of open source for the magic code snippet that reflects what you're trying to do, paste it in, and then you got working AI-generated code, right? Well, that sounds a bit tedious, right? You got to like do all this searching and crawling the code base, and then you got to like copy all this stuff in. And so what we really try to do is productize this act of copy and pasting through the use of something we call a code context engine. So this is a form of retrieval augmented generation, for those of you familiar with that term. And it basically takes advantage of a lot of the infrastructure that we've built over the years to enable human developers to understand messy code bases better. So things like code search and the code graph, the reference graph. And what we do is we have extensions that plug into every major editor, as well as a web application. And when the user request comes in the pipeline, we first consult the code intelligence graph. And that allows us to surface relevant code snippets. So this is the process. It's similar to the process that a human does when you're going through and trying to build up a mental model of the code. You read through a lot of the existing code to kind of acquire that context in order to set you up to write things effectively. And then we pass a lot of that context to a really good large language model. And we've actually designed our architecture to be model agnostic from the ground up. So we believe in freedom of choice. And those of you in the know that there's a bit of a space race in the landscape of foundation models right now. The leader changes every 6 months or so. Sometimes it's OpenAI, sometimes it's Anthropic. Google's coming up quickly. Meta is releasing all sorts of amazing open source models. And so we really want to preserve the ability to choose the best model for the task at hand when it comes to making AI useful in your code base. So we get the output from the language model, we have a fact-checking step against the code intelligence graph, and then we pass that back up through the UI in your editor or in our web interface. So enough me describing what that is. How about I actually like try to demo what that might look like? Okay, so who here has done computer vision before? Anyone? A couple hands? And most of it, who here has not done computer vision at all? Okay, me neither. But let's try to use the benefit of this tool to try to write something working from scratch. So I'm inside the Cody web application. So it's kind of like a ChatGPT-like interface. But the main thing that we add here is the ability to target a particular repository. And so I'm not a computer vision person, but I've heard about this trendy new library called Supervision. A friend of mine wrote it. It's pretty new, so it's not really made its way into any of the training data of the frontier models. So I think this is a pretty good example to use that approximates the experience of trying to tag in a private library package that you might have inside your private enterprise code base. So let's write an object detector. So write a Python script that detects all the someone have a favorite object class, like pedestrians or cats or dogs or buses, all the buses in an image. Okay, I'm hoping that the underlying computer vision model here has a class for buses. Okay, it seems to have a class for buses. Okay, let's see. So a couple things to point out here. The first thing it's going to do is when I ask this question, the first thing it's going to do is going to fetch relevant code snippets from this repository, and then use that as context to generate the code. So I'm going to copy this generated code and paste it into my editor. And I guess I need an image. So let's download an image. I guess we could use this one. And let me get the path to that image that I just downloaded. How does this look? Everyone see that? Okay, cool. All right. So I'll say a prayer to the demo gods. See if this works. All right, so did something. Output with buses. There we go. I don't know if that's visible, but there's a yellow bounding box around that bus. It's pretty cool, right? So here we've written a basic object detector targeted at a specific library that's not represented in any of the training data using the power of code search plus AI. So that's pretty cool. How am I doing on time? Do you want to do another example, or do you want to move? Let's do another example. I think this one's pretty cool. So it doesn't also do images. We can also, this library also does videos. So let's see, it detects all the pedestrians in a video. So let's just make sure that wasn't a fluke. Oh, I have a typo. Where's the typo? Oh, that detects. Thank you. That probably would have thrown off the quality of the output. One other thing to call out here, too, is I'm using Claude 3.5 Sonnet, so we try to integrate the best model for the job. We also have this prompt library, so sometimes it's helpful to bake in some institutional knowledge. So if you use a particular library, you might have a bag of tricks, and you can actually modify the default prompt that's available and share that with your coworkers. Typically very helpful for making AI practically useful in code bases. And then I believe I have an existing video. So this is a video of just people walking around. Okay, so let me copy that in, and we'll paste that in. We'll run that, see if that works. Oh, it's got to download a new model. All right, I'll talk some more, I guess. The basic idea here is pretty simple. So the idea is that you really need two things to make AI effective. You need a really smart model, and so you want to be able to use the latest and greatest frontier models, and that's something that we offer. And then the other important part of the equation is the context. So this is where the quality of the search results really comes in. And so I think we're one of the only AI coding assistants to actually expose all these examples to the end user. It's because these examples are actually pretty decent quality. And so I guess we'll wait for the model to download. This is just proof that this is actually a live, real demo. Anyone want to take bets on whether this will work or not? Who thinks it's going to work on the first try? Ooh, a lot of you. Wow, you have great confidence in AI. All right, anyone who thinks it's not going to work? There's a reasonable chance that this might not work. Well, let's see. Oh, there we go. We got people detectors in a video. And so I can't claim full credit here because, look, we didn't write this computer vision library. All we're doing here is context-aware code generation. So this is really about making working code that better fits within the context of a specific code base, perhaps your private, at-work enterprise code base, and making the experience better. Avoiding hallucinations, avoiding having the need to constantly check and edit the output of LLMs. Okay, so enough about that. What's the tech that's powering this behind the hood? So I mentioned model choice. That's simply a matter of integrating and evaluating the latest models. We'll get into more of that later. But the tech on the context side is we constructed this thing called a code context engine. And there's a couple ways to think about this. Anyone here familiar with like search engine architectures at all? Do like information retrieval? A few of you, one or two of you. So context engine architecture actually looks pretty similar to a traditional search engine architecture with a couple of notable additions. So in a traditional search architecture, you typically have like a two-layered architecture where layer one is kind of your recall layer. So the point of layer one is like you don't want to miss anything. So if I'm searching for something, you want to make sure that whatever it is I'm searching for made it into the set of candidates that you're going to propose up to layer two. And then it's layer two that's really, its job is to take the kind of like broad overset, noisy set of results and filter that down to something that's very precise. And so our context engine architecture works in a very similar fashion. And the underlying retrievers we use, it's a combination of multiple things. So vector search is obviously like very hot. I think I saw a couple of talks elsewhere in the conference about dense vector search. Those are cool. We make use of that. But we actually also make heavy use of just like classical BM25 search. Believe it or not, like that's still heavily useful in this RAG pipeline. And one of the key pieces of our pipeline that sets it apart from a lot of other pipelines is that it's syntax aware. So whether we're doing BM25 search or dense vector search, we actually go through and understand each code file as a collection of symbols and references rather than just a blob of text. And it turns out that's really important for reasoning about these chunks of code in a way that's effective for purposes of code search and context retrieval. We have a couple other context fetchers as well. Those get fed up to layer two, where we have a re-ranker that's essentially learned from data. So we take a look at all the data that's been useful. We take a look at the output of the LLM. And over time, we've constructed a data set that is pretty good at picking out from the layer one candidate sets the things that are most relevant to the user request. Another thing that's really important for us is evaluations. So we have a pretty substantial evaluation suite, both for context quality and the overall quality of the LLM output. It's a combination of painstakingly human-labeled data coupled with synthetic data that reflects the types of queries that we see. And this is something that is pretty important because there's a lot of like academic benchmarks out there about like LLM quality, like human eval and things like that. And though we find that there's still some signal in those benchmarks, we find that there's a lot that they don't capture about real-world usage in production code bases. So we've invested pretty heavily in our evals, and this allows us to essentially, whenever a new model comes out, we plug it into the eval pipeline to determine whether it's useful to roll out or not, and it also gives us a sense of like what it's good at. Okay, so we have a solution for collecting context from your code base, because that's really important for making AI useful in your private code. But there's also some important context that's outside your code base. So maybe it's in your issue tracker or your code review tool, in your code host. Maybe it's in like Notion or Google Docs or Jira or Linear, one of those tools. Maybe it's in your production log, so Sentry or Datadog or things like that. So how do we pull in context from that? Because as a human developer, you're constantly cycling through these tools when you're inside the software development lifecycle, right? It's not just your editor that's important, not just your terminal, but all these other tools that provide useful context for you. And our solution here was to come up with a protocol that is a way to get these other sources of context into the code base. So how many people here are familiar with the language server protocol, LSP? So it powers a lot of the kind of like editor plugins today. OpenCTX, which is our protocol for context, is kind of like an LSP, but for technical context for LLMs. So the basic idea is you write two types of integrations. You write integrations into clients, so things like editor plugins and web applications. And then the second type of integration is a context provider. This could be literally anything that you might consult as a human for technical context, whether it's SemGrep, documentation, Jira, GitHub, any of those things I mentioned before. And if you write those two things, the context gets translated into this common protocol, which then gets fed into the client. So one of the things that you can do here let me just open up an example, is you can actually annotate your code with links to relevant context. So this links me to the docs on telemetry. It links me to the charts that we have in Prometheus. And not sure what this does. A Postgres table, which I don't think I have access to on this network. But basically, like, the context providers provide a way to link these other sources of technical context to specific items in your code. And so they're renderable in your editor when you're a human trying to read through and understand what's going on. And they also happen to be useful to LLMs. So one of the things that we've done is integrate these sources of context into our application. So I showed off the web app earlier, and now I'm inside the editor. And you can actually do things like tag in like a search query, or tag in an arbitrary web URL. So if I, copied and pasted this website, let's see, and then I can ask it to summarize what's on this page. And inside a production code base, this might be like some piece of internal documentation or some piece of internal context. This will actually attend to the context. So we make it super easy to pull in this context into the editor where you're trying to like use it to write code. So this gives a pretty good summary of OpenCTX. I can ask it things like, how do I make an OpenCTX provider? I can either read the docs, which are visible here. So like to create a provider, you just have to implement this simple JavaScript object interface. Or I could just tag it in, and this kind of gives me an example of doing the same thing using the same amount of context. Okay, so I've claimed that it's pretty easy to add a new context source to Cody, but how easy is it? Well, what if we tried, I don't know, 13 minutes left. How about we try to add a new context source to Cody, using, of course, Cody in open context. So what I have here is I have open the Cody repository, and I have open, I've taken the liberty of doing some basic setup. So what I have here is this copy of that web URL provider that I just demoed. So I basically just copied pasted the existing provider that allows me to tag in website contents, and it's available inside my editor as web URLs copy. And right now the behavior is unchanged. But let's say I wanted to add a new context source. So one of the things that I consult as a technical person is HN. Who here reads the front page of HN? Okay, cool. A couple of you. Oh, not as many as I would have thought. Maybe it's past its prime or something. What do people use these days? It's like TikTok or something? Okay, so let's try to add like a context provider for HN. So how would I do that? Well, first I need a way to fetch the HTML on the HN homepage. So inside Cody in my editor, I can ask, write a TypeScript function to fetch the HTML of the HN homepage. And you'll notice one thing here is that I'm not using autocomplete that much. Like, we do provide autocomplete, but we're really trying to move a little bit beyond the autocomplete paradigm because we think the more impactful usage of AI is in these kind of like more intentional modalities where you're describing what you want and you can get kind of like a whole function and maybe like an attending unit test along with it. Because if you're able to do that, you never have to kind of like get into the weeds of like line smithing something. You can kind of stay at the level of like, what am I actually trying to do? Okay, so let's see how well this works. So I'm going to put all my helper functions into a separate file. And this looks correct, but maybe I want to generate a unit test to make sure it's actually correct. Okay, so if I hit apply, it's actually going to put the unit test into a file called hn.test, which is reasonable inference. And there's some errors, so let's see if I can fix some of these. Okay. So what's the error here? Oh, I need to go export this. Let me go back. Export this. Let's see, oh, maybe I'll add all missing imports. I'll ask Cody to fix this. Okay, still have some errors. Okay, maybe this example won't work as well. Well, it gets me all the way there, and if I had more time, we could probably fix this. But let me just go on to the other parts of this demo. So let me hop back into chat, and what I can do is I can tag in the current file. So get my current file up, and now let's say I want to write a function that extracts the title and URL of each article on the HN front page. Okay, so it's going to use the function that I just wrote, and we call this paradigm kind of like chat-oriented programming, because we're really at the level of like trying to describe what we do and trying to lean as heavily on the AI to write as much of the code as possible. Okay, so it generated this file. I'm just going to copy and paste this in. It looks like we have a function for extracting articles now. So now I'm going to hop back over to index.ts, and I'm going to highlight this whole thing. And I'm going to use this interface for tagging and context. So in this case, I only want it to attend to this context and maybe the context of hn.ts. So I'm going to say modify index.ts to return the list front page HN articles in the mentions endpoint. Use the helpers in hn.ts. Okay, so we'll see how this works. Okay. All right, so it looks like it generated a replacement for the code I have here. So let me just go in. I'll ask Cody to fix some of these errors, see if it works. Okay, it generated a fix. Okay, and we haven't implemented that function, that's okay. And let's see if Cody can fix this. So I'm trying to lean as heavily on Cody as possible. Okay, so let's see if that works. So do I have this running? Okay, it's complaining that this is not used. Oh, you know what? I might have to, here, let me go back. I think it removed this default export. So let me just add that back in. Okay. Still find some test errors, but let's see if this pops up in my editor now. Okay. So now I have an app mention thing for Hacker News, and when I hit enter, it fetches articles from the front page of HN. So let's just go over to HN, see if this is actually a live demo. What's on the front page? At the top is that article. So long WordPress. So here what we've done is basically use Cody to add a feature to Cody to add a completely new context source to this tool. Any questions? Did I lose anyone? So most of this is just try to demonstrate the fact that we're kind of attuned to the experience of working in existing code, because I think that's where AI becomes most effective. There's a lot of cool demos out there that show how to create like simple React apps or like a Flappy Bird clone, and LLMs are pretty good at that because of the way they're trained. But I think what we've tried to do is create an open system that actually works in the context of production legacy code bases, because frankly, as a professional developer, that's like 99% of my day-to-day experience. Okay, I don't have much time left, so I just want to cover real quick a final thing that we've done to make AI more effective in production code bases, and that is fine-tuning large language models for better contextual awareness. So I've talked a lot about the importance of context, the context that we fetch, the quality of the code search that we use, but all that is for naught if the model that we're feeding the context into isn't smart enough to actually learn from the contextual examples that we're giving it. And in some use cases, it's actually kind of difficult to come up with a model that is context aware. So in very latency sensitive use cases like inline autocomplete, you tend to want to use a smaller model because smaller models are faster. And this diagram is a little bit complicated, but basically what we're doing is at the top here, you basically have the prompt that we're feeding to the autocomplete model. So there's the cursor position, that's where the user's cursor is, and they're trying to do a completion here. And we're testing two models. One is StarCoder, 16 billion, and the other one is DeepSeek Coder V2. And the issue that we found with StarCoder, that was the model that we were using originally, was that even if we found the perfect context example, which is this thing at the bottom here, the decode refresh token, that's kind of like exactly the function or the example that we want, we passed that, and StarCoder, because of the way it was trained or because of its small size, wasn't actually able to make use of that context example. And so it didn't emit like working code. But we found with DeepSeek a better in-context learning ability. And so that's informed which models we make available and prefer inside Cody. And so if you think about like what sort of like trade-off curve you're looking at when you choose LLMs for specific tasks, how many here are familiar with like efficient frontier or like Pareto, optimality, portfolio theory? Okay, so in machine learning, there's this notion of like, you don't always have a single metric that defines what good is. Sometimes there's multiple dimensions. And in our case, there's two things that you care about. One is latency, how quickly can I get a response? And the other one is quality of the code generation. So here I plotted latency on the x-axis and quality on the y-axis. And so it's very easy to trade off latency for quality. Like if you want a faster performance, you just select a dumber model. You know, you'll get faster performance. So that's why this curve kind of slopes upwards. But what you really want to do is move up into the upper left-hand corner. And that's much harder to do. It's much harder to improve quality while preserving latency or even driving latency down. But because we are doing this kind of like eval stuff, when a new model comes online, we can basically say like, oh, like let's see where it lands in this kind of two-dimensional space. So that's informed the selection of models. We moved from StarCoder 16 billion to DeepSeek Coder V2, 2 billion. It's actually smaller models, but smarter and faster. And then the second thing that we've done is not just use the off-the-shelf model that's better, but we're also, we have collected like a fine-tuning data set. So we see what completions are accepted and rejected by users, and we can roll that back into the training data of some of these models to further improve the frontier. So with the benefit of fine-tuning, we're able to improve the performance of DeepSeek Coder V2 by another extra percentage points. And this all feeds into Cody, the application that you saw, where we track sort of like end user metrics. So this is like the academic benchmarks, but we try to correlate these with in-product metrics as much as possible. Things like completion acceptance rate, which is like how often are you accepting the completions that we propose. Okay, so I'll take a quick step back. With AI, it's always important to ask like what is hype versus what is actually helpful. And so I just want to like level set expectations. I don't think AI can do any of these things effectively today. It cannot write precisely correct code in your area of domain expertise. It's going to fail at that. Humans are still much better at doing that. It cannot guarantee code correctness. It cannot work well in existing code bases without a lot of human guidance and supervision. And so a lot of the demos that you see online, they're in greenfield code bases. They're creating apps from scratch. And it's very impressive because a lot of that stuff is legitimately difficult or takes a long time for humans to do. But when we talk about actual production code that drives user value or revenue, 99.9% of that code is legacy code. And so what we're really focused on is making the tool that works best in those scenarios. And so what is AI good at today in production code? Well, we think it's these 5 things, this acronym DRAFT. So it's good at discovery. So it can help you search and pinpoint where stuff is located. That's something that we've done for a long time. We're traditionally a code search company. It helps you ramp up on new libraries. So like that example I showed you with the computer vision and object detection. Like I'm not a computer vision person, but I was able to spin up an object detector very quickly and get to working code very quickly. It's good at helping you apprehend new concepts. So once you're in a code base and you're unfamiliar with it, you can actually use it to explain how different functions work and how they connect to each other. It's good at helping you maintain flow state. So to the extent that the functions that you're generating, you can generate in that kind of like chat-oriented programming style that I showed off. That helps you stay in flow, because the less you kind of dive into the weeds and have to go on like these small side quests to distract you, the more that you can keep your eye on like what it is you're trying to accomplish, the feature that you're trying to search. And then the last thing is it can help you get rid of tedium, things like writing documentation, generating unit tests, and other things that aren't super interesting for creative humans like ourselves. I'm going to skip this slide because I think I'm basically out of time, but we've also done a lot of work with companies to measure the ROI. So I'll just leave it at this, like measuring the impact of AI on developer productivity. It's a very hot topic these days. The thing that I'll observe is that being able to measure the impact of AI tools on dev productivity implies that you can measure developer productivity, which who here knows how to measure developer productivity? Okay, so that's why this is a problem. And so we've come up with like a couple of frameworks. If you're interested in that full talk, you just scan that QR code. That's a whole like other can of worms or can of beans to talk about that. What does the future code look like? We believe that it should be open source tools for individual devs. I think right now we live in this weird kind of halfway in between state where a lot of the existing AI coding assistants are proprietary. We think that the world is just going to naturally evolve toward more openness. We do think that there's a place for proprietary systems for things like enterprise search and things like that. But we think that individual devs they will use open source tools. That's just the natural pull of what devs want to use. There's going to be more and more automation over time, but it's going to take time. Like self-driving cars. I remember reading about that back in high school, I think, the DARPA Grand Challenge. And here we are in 2024, and my Waymo still is limited to like the 7x7 mile grid of San Francisco and hasn't gone beyond that. So it's going to take more time. We think it's going to automate away toil, not humans. So I think this whole like AGI, AI is going to make all of us irrelevant. It's a lot of like fear mongering, quite frankly, that I think is not very constructive. And the thing that we're excited about is just automating away the boring parts of the job so that we can get to the fun stuff. The quantity of the code, I think, will increase by orders of magnitude. And that's not necessarily a good thing. Like every developer knows that the volume of code you write isn't necessarily a good thing. You don't measure developer productivity in terms of lines of code generated for good reason. But we want to focus on making the tools that understand all the code that's generated and help humans make sense of that and manage that. And then finally, I think context is an important part of this equation. Just the underlying LLM itself is not going to be good enough. You really need good context and code search tools to make this valuable for real-world code bases. So that's the end of my talk. If this is interesting to you, you can try Cody out at this URL. It's also open source, so if you want to star or contribute, we do take community contributions as well. And we're hiring, so if you're looking to join kind of like a forward-thinking, developer-focused company, stop by one of our booths. We have one just outside this room and one downstairs as well. Thank you.